Good morning, everyone. I'm Laure, Fallou, Research Officer at the ENSC. I'm very pleased to present today the results of a survey we led on perceptions and reactions to an actual public earthquake early warning. So far, earthquake early warning research has mainly focused on technical and seismological aspects. But to ensure their true efficiency, these warnings need not only to be delivered to the public, but also, and most importantly, to be understood and trusted. In this respect, it is of higher importance to study the public reactions and perception of this message. This is what we did with a very specific public earthquake early warning, which is called Earthquake Network, and which I will refer to as EQN for the presentation. So, Earthquake Network is a system based on an app that has 6,050 active users in 2020. The system used the smartphone accelerometers to detect in real time the shaking induced by an earthquake. So basically, once an earthquake is detected, it issues a warning and sends it to all the smartphones of the network in the area. If not too close from the epicenter, users may then receive it in advance and thus benefit from an earthquake early warning. I'm not going to focus on the technical aspects here. You can read the paper referenced here or check Francesco Finazzi's presentation on the matter. But what you need to know is that the warning is composed of a simple message and a specific sound. It comes with a countdown and a map. The app is free to download in its basic version and it can be run all over the globe. It's available in 8 languages. Contrary to national earthquake early warning systems, EQN is a bit specific, so it's voluntary and it's community-based. So, indeed, first, users have to download the app to receive the alerts, so that's why it's called voluntary. And secondly, the more users, the more efficient the system, so that's why it's community-based. We study here a warning sound related to an earthquake that happened on May 26, 2019 in Peru. It had a magnitude of 8 and it caused moderate damages and sadly 2 deaths. It happened at night and it was felt largely in several countries. And for this earthquake, EQN launched a warning to some of its users. And what we did here was to launch a questionnaire that tackled several issues. So first we wanted to assess EQN users' expectations for earthquake early warning. We wanted to assess the warning understanding. We also wanted to collect reactions following the warning. And finally, we wanted to rate tolerance for missed and false alerts. So the survey targeted all EQN users who were in the region at that time, and it was launched online in Spanish. Invitation to fill in the questionnaire was sent to EQN users through a pop-up message that user could see when they opened the app. Data was collected between July 23rd and August 19th of 2019, that is to say a few months after the earthquake. And during the data collection period, few earthquakes occurred, and no early warning was issued by EQN in the area. And in total, we collected 2,625 answers, which is a pretty large number of users, and we were pretty happy of the database we had. What did we find? So the first interesting result is probably that the very high level of interest for earthquake early warning. It's actually the first reason to download the app for users. This is consistent with the fact that before the earthquake, there were 33,000 EQN users in Peru, but that number rose up to 150,000 users 2 days after the earthquake. Another fun fact, maybe, so we did interviews before launching the questionnaire just to get a sense of what was happening in the country. And one of the interviewees reported that people in Peru started buying Android smartphones to replace their Apple just to get the app, as it was not available on iOS at the time. The results you have here on the graph also reveal the importance of the community aspect, as it is one of the reasons to use the app. As you can see, the third reason, it shows that will to be a part of the network and increase the quality of the seismic data in the country. When we launched the survey, we had no way to know for which users the warning had worked, so we asked them. We asked respondents to tell us whether they received the warning and whether they felt the earthquake, and if necessary, if they felt it before or after receiving the warning. So we have here a picture of what they actually experienced. It turned out that the warning worked perfectly for 41% of the respondents, either because they received the warning in advance or because they didn't receive it and didn't feel it. There is still a significant share of the respondents who experienced missed, fall, or late alerts, as you can see. However, we don't have enough data to know precisely where these people were and why they didn't get the alert, for example. It's possible that the respondents were too close or too far for the system to be efficient. It's also possible that they turned off their phone, for example, if they were sleeping because the earthquake happened at night. So we focus here on the 34% of the respondents who received the warning before feeling the earthquake. We wondered what their understandings and reaction were. So we found out that 79% understood correctly the message, which is a pretty positive results when we know how important it is for a warning to be understood to be efficient. And on the whole, a majority of respondents felt alerted rather than anxious, so that's also pretty good. When we looked a bit more in detail, so you don't have the results here, but we did some more research, and we found that those who didn't understand the notification felt proportionally more confused than others, and that having previously received an earthquake early warning notification slightly raised the probability both to understand and to stay calm when receiving that notification. From a risk management perspective, we often hope that earthquake early warning will enable the public to drop cover and hold on or to take safety action. Was that the case here? Not really. Only a quarter of the respondents did take a safety action. This is actually consistent with previous research, especially Nakayashi findings on how the public was mentally prepared, which is here represented by the option I waited for the first vibrations. And actually, despite the fact that they didn't drop cover and hold on, 75% of the respondents declared that the warning was useful to them. This tends to show that emotional preparation is really valued by the respondents. Another result that may be of interest is that understanding the notification was found to significantly increase the chance to take effective action. But what really surprised us here was the social dimension of the warning and how the most common reaction is actually to warn others, whether they are physically present or not. We probably need more research to understand to what extent this is linked to the fact that it is a voluntary system. So as I said, you have to download the app. So that means not all Peruvians can benefit from the system. It's not a universal warning. Now let's talk about users' perceptions of false and late alerts. So when asked about how they felt when they received the warning notification, even though they had already felt the earthquake, AQN users who were in this situation declared mixed feelings. For some of them, the notification had added up to the anxiety, and they thought another earthquake was going to hit. But an equivalent share declared, on the contrary, that they felt relieved, that information helped them decrease their anxiety level. Despite this late alert experience and the fact that 12.7 of them trust the app less, nearly a quarter still feel confident that the system will work in the future. When it comes to respondents who received the warning but never felt the earthquake, half of them declare a high level of confidence in the fact that the system will function for future earthquake. And among the other options, Many EQN users explained that they were probably too far for the system to function well, or that they had changed their app parameters. However, these false alerts still raised anxiety for 90% of users as they waited for the shaking. These results, in the end, tend to confirm findings from ANENET-HAN in 2018 that there's a general acceptance for the technical limitation of public earthquake alert warning system, and that users are more tolerant of unnecessary alerts than of missed alerts. Just a few words to conclude. So, overall, in the earthquake early warning landscape, EQN stands in a very specific position, as I said, because it's a voluntary and community-based system. So what did we learn about its strengths and limits? First, we saw that it clearly met a need where no public earthquake early warning system exists. In the end, it's a rather easily accessible and it's free. It only requires a smartphone and an internet connection to work. So that we can really bring this service where it doesn't exist yet. We learned there's a general good understanding of the warning and a good tolerance for false and missed alert, for the moment at least. Indeed, this may be enhanced by the community aspect of the app. And finally, if most of the respondents didn't take a protective action, they still think it's useful and they got the chance to mentally prepare it. But the social dimension of the alert may actually be a limit to EQN warning for now, as people wanted their relative to be warned also. And this idea of earthquake early warning as a public service that should be available to all, not only because it would be fair, but also because it would be more efficient, has been expressed by EQN users. There were 54% to think it should be a state responsibility to run such alerts. Of course, EQN can add a share button to share the alert quickly. The role of the national institution still appears important here. And I will just conclude on future work. So we're currently working on systematizing this survey, which will enable us to study, for example, the existence or not of warning fatigue, but also to identify potential cultural differences in the way people react to these warnings. And as more and more systems develop, another question will be what will happen in case of multiple earthquake early warning provider at the same place, which is going to be an even bigger question as Google starts to provide this kind of service in certain areas of the planet. Thank you very much for your attention. I'd be very happy to answer your questions if you have one.